Lesson 68, probability multiplication rule, and then our appendix lesson that goes along with finding slope of 2 points. First off, let's look at principles and rules. A fundamental counting principle states that if an experiment has two parts, the first part with m possible outcomes and the second part with n possible outcomes, then the total number of possible outcomes for the experiment is the product of m times n. So we're going to be using the fundamental counting principle today to solve some probability problems. And then the multiplication property or multiplication rule for probability just states if events A and B are independent, which means they don't affect each other, then the probability of getting A and the probability of getting event B, you multiply those two together to get our answer. So let's take a look at an example. How many possible outcomes are there for an experiment in which two number cubes are rolled together? So here you have a diagram with one number cube on top and a second number cube on the side, and all the possible outcomes you can get. You have 6 rows of 6, so 6 rows of 6 will give us 36 total outcomes. Now we're going to use that 36 to answer some other questions. It says two number cubes are rolled once, just like you see in the diagram there to the left. How many possible outcomes are there which the first and second rolls are both even? So how many possible outcomes are there for which the first and second rolls are both even? So we need to find out how many with the first roll where the solution is even. Now if I use my diagram, now both number cubes have to be even numbers. So there's 1, here's 2, here's 3, 4, 5, 6, 7, 8, 9. That is 1. We could say it's 9 out of 36, which if I divide by 9/9, I would get 1/4. That is one way of thinking about it. Another way is on one number cube, you have 3 even numbers out of 6 choices. The second number cube, you have 3 even numbers out of 6 choices. If I multiply those straight across, you would get 9 out of 36, which reduced would give me 1/4. Or you can think of it as half of the numbers are even on one number cube, half of them are even on the other number cube. That still gives us 1/4. So there's 1 out of 4 chances of you rolling both evens. Next one, 2 number cubes are rolled. What is the probability of rolling a number greater than 4 on each number cube? So the first number cube, greater than 4, there are 2 numbers out of the 6 that are greater than 4. The second one, there's 2 also greater than 4, so 2 out of 6. If I were to multiply those together, I would get 4 out of 36, which reduced by 4/4 would give us 1 out of 9. So that would be the probability of rolling a number greater than 4 on each number cube. And again, with these, going back to our principles and rules, we're using the multiplication rule for probability. Event A times event B. And going back to here, event A was one number cube, event B was the second number cube. So we're just multiplying those two together. Next one, a coin will be flipped 4 times. What is the probability the coin will land heads up all 4 times? So for these, I have four events. So the first chance, event 1, I have 1 out of 2 chances of letting it on heads. The second time, I have 1 out of 2 chances. The third time, I have 1 out of 2 chances. And the fourth time, I have 1 out of 2 chances. If I multiply all those across, I get 1 out of 2 times 2 is 4, times 2 is 8, times 2 is 16. So I would have 1 out of 16 chances of all of them landing on heads. Next one, suppose the bag contains 3 red and 3 blue marbles. Robert selects a marble from the bag and looks at it and then replaces it. Then he selects a second marble from the bag. What is the probability that he selects a red marble and then a blue marble? So we're trying to find the probability of getting a red times the probability of getting a blue. So the red ones, there are 2 out of 5 total marbles that are red, and 3 out of the 5 are blue. So if I multiply those together, 2 times 3 is 6, 5 times 5 is 25. You would get an answer of 6 out of 25 chances. Maribel holds a stack of 52 alphabet cards, 26 uppercase cards, ABC all the way to Z, and 26 lowercase, ABC all the way to Z. She shuffles the stack and selects one card. What is the probability that is an uppercase vowel? So for this one, we can solve it a couple ways. We already know that there's a total of 52 cards. And out of those 52 cards, there are 26 uppercase. But out of those uppercase, how many of them are vowels? And vowels are A, E, I, O, and U. So that is 5. So 5 uppercase vowels out of the 52 would be our probability of choosing an uppercase vowel. Another way of thinking about it would be you have 2 opportunities. You have 1 out of 2 chances of getting an uppercase versus lowercase. So half of it is uppercase, the other half is lowercase. So that's 1 out of 2 chances of getting an uppercase. And a vowel, 5 out of the 26, because there's 26 uppercase, 5 out of 26 would be uppercase or vowels. So if I multiply that, I would get 5 over 52. Those are 2 different ways of getting the same answer. Next one, in a certain experiment, a coin is tossed and the spinner is spun. Compute the probability of events in A and B. So A, probability of getting a heads and blue. First off, the probability of getting heads is 1 out of 2. Probability of landing on blue is 1 out of 3. So if I multiply 1/2 times 1/3, I would get 1/6. So I have 1 out of 6 chances of getting heads, landing on heads and spinning a blue. And B, getting heads, 1 out of 2, not blue. 2 of them are not blue, so 2 out of the 3 are not blue. That would give us 2/6, which reduce, divided by 2/2 would give me 1/3. On the last slide, looking at our appendix, find the slope of line from 2 points. So using the slope formula, which is y2 minus y1 divided by x2 minus x1. Suppose a 6-mile taxi ride costs $15 and a 12-miler taxi ride costs $27. To use the data points 6:15 and 12:27 to find the slope. x1, y1, x2, y2. So 27 minus 15 divided by 12 minus 6. Here we would get 12 divided by 6, which would give us a total of 6. So $6 per mile. Let's find the slope of these. So we're getting x1, y1, x2, y2. -4 minus 2 divided by 2 minus a -1. -4 and minus 2 is -6. 2 minus a -1 is 2 plus 1, which is 3. Gives us an answer of -2. Next one, I have -1 minus a -7 divided by 3 minus a -5. When I'm subtracting a negative, I'm really adding its opposites. So when I solve this, -1 plus 7 is 6. 3 plus 5 is 8. Divide by this by 2/2. This would give us 3/4. So our slope is 3/4. The last one here, x1, y1, x2, y2. So 4 minus a negative 2 divided by 3 minus 3. Here 4 plus 2 is 6. 3 minus 3 is 0. I cannot divide by 0. That would mean this is undefined, which would mean I have a vertical line. That is our lesson today on find probability multiplication rule and find the slope of 2 points.